Hello everyone. So in this video, we are going to go through a constraint question in which we have to generate a pattern which goes something like this: 1 1 2 2 3 3 4 4 5 5 and 6 6. So the pattern should be something like this, and we have to perform this pattern using the constraints. So let's begin. So there are multiple approach of doing the uh, of generating this pattern. So first, let's just begin with our class, and let's name this class as conf. And inside this, first I will declare a dynamic array which will have this pattern. So I will declare it as rand, and it will be randomized, and all of its elements will have this pattern. And I want every element to be of int data type. And let's name this A, and the empty square brackets indicate that it's a dynamic array. So first I will write a constraint which will limit its size to the given pattern. So if we will go through this, we will know that the size of this pattern is 12. So there are 12 possible values. So that's why our very first constraint will be to limit the size of the dynamic array A to be of 12. So let's write that. And I will just use the size method. And inside the constraint, if you want to equate something, you have to use to equal to operator. So two assignment operators should be used inside constraints. So I will write it 10. And you also have to put the semicolon inside the constraint, but you don't have to put the semicolon outside the curly brackets. So it should not be 10, it should be 12 actually. So this concludes our size, and then we will write another constraint which will generate this particular pattern. And I will be doing a brief walkthrough in which I will explain that why I used this particular algorithm to generate this pattern. So I will write another constraint, and this time I will call it pattern, a underscore pattern. So there are multiple approaches. So first I will go through the brief approach, which will involve a bit more code as compared to the compact one. So what I will do in the brief approach is that I will just divide the entire range into two possible patterns. The first one accounts for all the patterns that appears at the element which is of even number. Suppose the first element is 0 and 0 has 1, and the second even element is 2 and 2 has 2. No, yes, and the third even element is 4, which has 3. Similarly, the other category will be the odd number of elements, and it also has 1, 2, 3, and 4. So let's begin. So I will be dividing the entire, I will be writing some conditions which will focus on even elements and the odd elements. So the even elements will be uh, the 0th element, the second element, the 4th element, and the 6th element. And the odd elements will be the first element, the third element, the fifth element, the seventh element. So and so on. So after 6, whichever element comes in the even, and after 7, whichever elements come in the odd arrangement. So let's try to imagine the pattern. So I will begin with the even elements. So I will put a condition, and to point, first I will write a for each loop which will iterate through every elements of the A array, and as per our constraint, they are going to be 12 elements and which are required as per the pattern. So it will iterate through 12 elements. So I will divide the category into two things, the even elements and the odd elements. So to point to the even elements, you just have to use the modulus operator. So if you divide the iteration uh, by 2 and it results in 0, then which basically means that if you divide 2 by whatever the iteration is and the remainder is 0, then then it is an even element, because in even element, in even number, if you divide that by 2, there won't be any remainder left, whereas in the odd number there will be a remainder. So our first if condition focuses on the even elements. So let's find out how can we generate this particular arrangement. So as you can see, we will just divide the numbers. So uh, if you will observe that the 0th element is 1, and then the second element is 2, and then the fourth element is 3. So there is a similar pattern that the number are getting iterated only by 1, even though the elements are 2 or 4. So we have to find a way uh, in which we generate this pattern by using the iteration variable. So if you try to imagine this, you could do that very easily. So first, what I will do, um, what are the possible scenarios that can generate this pattern? So there is a requirement that our first element or the 0th element should be 1. And what is the what is the value of the I in the 0th element? It's 0. So it is clear that the 0th element which comes under the even element category should be 1. So I will go ahead and write I plus 1. So I plus 1 ensures that the 0th element will get 1. But what about the second element? And if you try to omit the second element, that is the value of I with 2, then if you will add it, it will be 3, which is not our desired pattern. As you can see, our desired pattern should be 2, then 3, even though the elements are even. So you could just solve this by dividing the even elements by 2, so that the element, if you divide the even elements by 2, they will become uniform. So if you divide 0 by 2, it will be 0. If you divide 2 by 2, it will be 1. If you divide 4 by 2, it will be 2. And if you even divide, let's say 6 by 2, it will be 3. So at the end, you will get the value of I in such a way that it will be from 0, 1, 2, 2, and 3, which will make things very easy for us. So what we can do, we can just simply uh, we could just simply write minus I divided by 2. So let's try to omit all the elements and let's see what we will get. So if you omit 0 with this, then 1 plus 0 will be 1 minus 0 by 2, which will be 0. So we will get 1, which is correct for our first element. And in the second element, let's see what we will get. So in the second element, we will get something like this: 2 plus 1 and minus 2 by 2. So 2 plus 1 is 3 and minus 2 by 2. 2 by 2 will be 1. So basically it's 3 minus 1, which is 2. And it satisfies our need for the pattern because we want this second element to be 2. So it worked for the second element. So let's find out whether it works for the fourth element. So let's try to omit the value. So here we have I and I plus 1, and this time I is 4. So 4 plus 1 minus 4 by 2. So if we will solve this, we will have 4 plus 1 equals to 5 and minus 4 by 2, which is equals to 2. And if you solve that, it will be 3. So it also satisfies our fourth element, and it will also satisfy for the sixth element. So we have created a pattern successfully in which all the even number of elements will have a value from 0 to 6. So every time we get an even element, the value is getting incremented by 1 because of this simple algorithm. So we have cleared the pattern for the even number of element. So let's do the same for the odd element. The second, and if and if you do the modulus with 2 and the remainder is not 0, then it is odd. So everything else is odd. And if you get an odd element, then what will you do? It will be very similar to this. And here we will take the benefit of the automatic uh, integer conversion, because by default, if you perform any division and if you get a fraction, which you will get in the case of odd numbers because all the elements are something like this: the element number 1, the element number 3, the element number 5, and the yeah, the fifth element is the last element. So you will get something like this, and for this you want something like this, that the element number 1 should be 1, the element number 3 should be 2, and the element number 5 should be 3. So to achieve this, you just have to do a very simple thing. Uh, so what you will do is that first you will write I, because first you have to know that what is the value of the first element. So it should be 1. And how could you achieve 1? Just by simply equating it to the iteration variable, which will be 1 in our first case. So just by writing I, you got 1, which is satisfied. But if, oh sorry, it should be I, okay. But in the third element, it will not be true because you are just equating that particular odd element with the I. And in the third element, the value of I will be 3. Then the value here will be 3, which is not correct in our case. So just to correct this and just to create a pattern, you could just write minus I by 2. And it is very similar to the previous statement. So here, what you will get, so for the first element, let's try to omit this. So in the first element, you will get I minus I by 2. So if you omit the I with 1, you will get 1, and 1 minus 1 by 2. So this should be 1 minus 0.5. And here we will not get 0.5 after this division. We will actually get 0 because by default the default type is int and it is not real. So even though you will get 0.5 after this division by 2, it will automatically get converted to int, and the digits after the decimal will get neglected. So this will be 0. And what is 1 minus 0? It's 1. So you are just taking the benefit of the automatic conversion. And you could apply the same thing to the following patterns. So let's do it. So what will happen if we omit I with 3? You will get 3 minus 3 by 2, which equates to 3 minus 3 by 2, which is 1.5. But since it is automatically getting converted to int, we will rather have 1. And if you do 3 minus 1, it's 2. And the same thing will happen with the 5. You will have 5 minus 5 by 2, which equates to 5 minus, it should be 2.5, but since it is automatically get converted to the int, you will get 2. And by doing that, you will get 3. So there will be a continuous flow of this pattern, a repeated pattern, and together both the if and else condition will create the intended pattern of 1 1 2 2 3 3 4 4 and so on. So this is one of the ways that you can achieve this pattern. So first we will just try to run this code. So we are done with our constraint, and what we will do, we will write another function, and that function will be post randomize. And what you can do, you could just print the pattern values inside your top module, or you could also make it inbuilt to the constraint class itself. So you could do that by putting a display, a dollar display system task inside the post randomize. So you just have to write function void post. So whatever you write inside the post randomize, it will happen after the randomization. So the display will print the value when the randomization is done. So this is for post randomize, and here you just have to write the display task, and I will use that display task to print the achieved randomized value. So I would just write not randomized value, the pattern. So I will just write, even though we are using rand here, the pattern is not randomized. The pattern is, and here we will use %p to print the elements of the dynamic array. And here I will simply write the dynamic array A. So now, since everything looks fine, we will just go ahead and write the test module. And inside this module, I will declare the handle for the const class. And inside my initial block, I will assign an object to the handle. And then I will just randomize, and I will do that using the assert, just to make sure that whether session is getting failed or passed. So I will write assert, and it's an immediate assertion, so I will write assert, and inside the bracket I will write c dot randomize, else we will get an error. Rand failed. So let's save the code and let's check whether I have made any typos by running the compilation. Okay, there are two errors. So the first one is in line number 25, which says that uh, oh, it's just a typo. It should be initial, not initial. So let's save the code and let's compile the code again. Okay, now it's fine. So I will go ahead and run the simulation. And test. So as you can see right here that we are getting the intended pattern of one intended repeating pattern in which each number from 1 to 6 will get repeated for 2 times. So as you can see right it is 1 1 2 2 3 3 4 4 5 5 6 6. So we did achieve the pattern by dividing the code. So here I just wrote the code in more details and I just simplified it. And I just thought my planning was that first I have to think about the first element and whether we are getting the how can we achieve the first element by simple addition or by simple assigning it to the iteration variable I. And then what I did, since it was uniform, uh, there was a I mean each elements, for example in here each even elements were getting incremented by 1, so it was uniform. So what I thought is to just subtract that by the half of the iteration variable because the iteration variable is jumping by 2. So it worked for our case, and here what we just took the advantage that the real number will automatically get converted to the int, and then that will get minus with the iteration variable. So there was a much compact approach for which you have to think, and that compact approach is instead of this you could just write. So first I will just comment this. So instead of this you could just iterate through each of the elements of the array I, and you could just write without using any condition, if or else or anything. I plus 2 divided by 2. So this solves everything. So here also you are taking the advantage of the fact that the default data type is not real. So what will happen in the zeroth element? You will get something like this: 0 plus 1 divided by 2, which will be sorry, it's not 1, it's 2, which is simply 1. And for the first element you will get 1 plus 2 divided by 2, which should be 3 by 2, or sorry, which should be 3, yeah, 3 by 2. And if you do that, you will get 1.5. And since the default type is int, you will get 1. So for all the odd elements, you are taking the advantage of the fact that they will automatically get converted to int. And other than that, this basically works. This is the same thing that we used right here. So this basically works for all the even numbers without any walk around. So what I will do, I will run the code for one more time with this particular algorithm. So I will save the code and let's just compile the code. Okay. Okay, and now I will run the simulation. So as you can see it right here that we are getting the same intended pattern without even doing that much. So it's all about planning and thinking. In my first approach, I just divided the problem into two patterns, into two sets of patterns in which yeah, I am generating the pattern for the even elements, and then I am generating the pattern for the odd elements. Here, I just packed both the elements or every element into this single condition. So both of them works really well. So that's it for generating a particular pattern in which each elements are getting repeated for 2 times and the numbers are ranging from 1 to 6. I hope you find this video useful and stay tuned for more. Thank you so much.